Good evening, students. So let us move on to the next topic of the chapter 2, structure of atom. Okay, so the next topic is the charge to mass ratio of electron. Charge to mass ratio of electron. So as already the electrons were discovered, the discovery of electrons was done now. Now the next attempt was for finding the charge to mass ratio. What was that ratio? So in order to find out that ratio, J.J. Thomson did it experimentally and found out the charge to mass ratio. So he again took those two electrodes, cathode and anode. As we already know, cathode is a negatively charged electrode and anode is the positive electrode. And so he again took the two electrodes which were placed in a thin glass tube and they were connected to the voltage supply V. They were given the voltage supply V. Okay. So as the voltage entered to the cathode, then to the anode, anode was made a hole over here. Anode was made a hole over here. So as the voltage was supplied, the particles started moving around the thin glass tube. Now what he did basically, he placed electric field as well as the magnetic field over here. This blue is shown by the electric field. This is the electric field shown over here. This is the electric field shown over here. And this is the magnetic field. A magnet is placed which behaves as a magnetic field. Okay. Which behaves as a magnetic field. Okay. So, and he observed the nature of the path of the particles. The particles you already know now, they are the electrons because the discovery of electrons was done till then. So he did this experiment in 1897, in the century of the 1897. And first of all, he only placed the electric field. He only placed the electric field. And he observed the path of the electrons was deviated and the spot was seen on A. And the spot was seen at the position A. So when the electric field was there, the spot was seen at the position A. Okay. So when electric field was there, just now there is no magnetic field. Just now there is no magnetic field. Only we have placed the electric field over here. Okay. So when the electric field, under the electric field, as soon as the voltage was given over here, the particles started moving through the hole. A hole was made in the anode and the particles started moving in the hole, and screen was placed behind the anode. A screen was placed over here, and at that screen the position of the particles was seen at position A. It was seen at position A. Okay. So later on he placed the magnetic field. Now this position is shown over here A. Why? Because electrons are negatively charged, and as my electrons move from here, they get attracted towards this positive side of the electric field, positive side of the electric field. Since the electric field has got two sides, positive and negative, they are connected to each other. It can be any external electric field. So to the external electric field, all the particles, because the particles are electrons, we already know now, and all the particles are attracted towards this positive charge. They are attracted towards this positive charge. So all the deflection, all the particles, all the electrons are deflected towards the A. They are deflected towards the A. Okay. Now when the magnetic field was placed, so what happened now? All the charges, all the particles, they got deflected towards the point C. When the magnetic field was there, then the deflection was towards C, at the position C, okay. And when he removed both of these external sources, the magnetic source as well as the electric source, when he removed all these sources, then he found out that the particles were moving as was seen previously, they were moving in a straight line and they were focusing on the point B, on the position B. Okay. So he got different positions over here. He got A, B and C, 3 different positions over here. So from those positions, he kept on experimenting, he kept on thinking what is going over here, why this is so happening. He kept on thinking, he kept on experimenting, and he found out that the deviation depends upon three factors. It basically depends upon the three factors, and the first factor on which it depends, it's the magnitude of the negative charge of particles. The magnitude of the negative charge of particles. So as the magnitude of the negative charge particles is more is the deflection. More is the deflection. If the magnitude of the negative charge particle is less is the deflection. It is directly proportional. The magnitude of the negative charge particles is directly proportional to the deflection. It is directly proportional to the deflection. Naturally, if the more of the electrons are coming over here, more of the electrons will get deflected, and the deflection is more. If the less of the electrons are coming, the less of the particles are coming, the deflection will be less. Okay. Now the second point on on factor on which it was depending was the mass. It was the mass of the particle. Lighter the particle, greater the deflection. Naturally, if somebody is lighter, it can move more. Okay. So if the mass of that particle was lighter, then the deflection was greater. And if the mass was heavier, because that heavy particle needs more energy, it needs more force to move ahead. But if a particle is very, very light, it can move easily through. So if the particles which were coming from here, from the battery, and which were coming from the cathode and to the anode, and from the hole which was made in the anode, they were coming. So my lighter the particles, if the particles were very much lighter, they were deflected more. They were very much deflected. Okay. So this is the hole. I must write over here. This is the hole, though it can confuse what it is. Okay. So it is the hole. Then the third factor on which it was depending was the strength of the electrical or magnetic field. That how much electric field or how much magnetic field we are giving over here, we are applying over here. The electric field, the external electric field, if we apply the electric field of the greater magnitude, then obviously deflection was very much greater. And also if the strength of this magnetic field was greater, if we place a magnet of heavier strength, so having a greater strength, magnetic field having a greater magnetic intensity, then also my deflection was more. Deflection was more. So he studied all these factors and he came to this conclusion. And after calculating all the things and keeping in mind all the observations, he made a rough idea, and that rough idea came out to be E by m ratio, which is the charge to mass ratio. Which is the charge to mass ratio, and that charge to mass ratio he had given as 1.75820 into 10 power 11 coulomb per kg, because the unit of charge is unit of electron charge, unit of charge is coulomb, and the unit of mass is kg. So the unit over here becomes coulomb per kg. So E by m ratio he had given 1.758820 into 10 power 11, and this ratio is termed as charge to mass ratio from his point of view, and this is accepted all over the world and was considered to be this much. Now in the next lecture we will be studying about the Millikan's experiment, oil drop experiment, in which he found out the value of the mass of the electron. He found out the value of the mass of the electron. Okay, so we will do that experiment in the next lecture. Okay, then thank you. Please share my videos. Please subscribe my channel. And if you have any doubt, you can ask me in the comment section. Thank you.